Hello, this is Jan. So I just started my simpleTree program and I will show you how you open a cloud. You do this under File Operations here where the mouse cursor is. You click on this symbol button and then you will get linked to a subfolder in your simpleTree project folder. It is called data folder and that's the most reasonable place to store your clouds. You can import some file formats. I use PCD, so I load my development cloud. I press open and now the file is imported. So it took several seconds, about 5 seconds. You get some information here. You can adjust the camera position with these buttons from above, from the 4 sides and below. So this is always good. Check first before you model a tree. This is a really good quality. That's why it is my development cloud. It's a quite small tree, like 15 years old cherry tree, and we see it's a pre-processed cloud, so not much noise left. We can get rid of it to show you one more thing. So I press the clustering button here. We have some isolated points in space, like here, here. I don't know if you can see it, but to get rid of those, or here is a larger cluster, I do one clustering. All I want to get back is the largest cluster, so one cluster number. We can ignore this parameter and we can leave this like it is. This means that the distance, if this algorithm generates 2 clusters, the distance between the clusters has to be larger than 2 centimeters. So if we would have here an occlusion gap and these points were gone, then this end of the branch would be gone. But I think it's fine to leave it like this. You can always load your cloud if you do an error. There is no undo button. So yeah, and I can make the size of the points larger. So now we barely have any noise left, but we still contain the amount of information. So I compute now the normals. This takes a little bit more time. One more thing. So you can see here that this was about the clustering, and you can see that from about 1.2 million points, still 99.74% have been in the cloud after this. So the majority was not removed during the clustering operation. Now already the normal computation is finished with the principal component analysis, and I can start using this button here, switch color. So I make the size again a little bit smaller so we can see better. This is the first principal component visualized. You have to get familiar with what this means. The second gives us already a lot of information, which you see might be interesting. So the stem is red and the little twigs are green, and that's an important stuff. So, and the third gives a similar property. So I use a combination of both, and for thresholding operation you can see the details in my publication. And now we have marked in red the stem and the branches in blue. So I can run now a tree modeling, and I will choose like this preset threshold. I will set this to 2. You can pause anytime and see what these thresholds are. So Prunus avium, this means cherry tree. This is especially for the cherry tree. I can activate find more, This was presented in Hackenberg et al. 2014. So when in the first cylinder detection routine not all points have been processed, it will operate the second and third time. So these buttons here are new and we can ignore them for now. I will explain in another tutorial. Ignore them means leave this number to 0. So this is a special stem modeling. But if we model the stem up to a height to 0 meters with this special method, we don't model it at all. We just model it with our advanced technique here. So you can play around a little bit. I adapt those. You could leave them like they are, but yeah, it's quite stable, this point cloud. So I press here compute. This is also, I will show in another tutorial how to get those. I leave this and I want to use the allometry approach. It is explained in my publication. And I will also do a parameter optimization. I want to find 4 times a better parameter than the actual one, and I try to find a better one by having 41 or 40, it does not matter so much, randomized new parameter sets. So I click optimize parameters and now I click pause because it takes a while. So I'm back now. The computation has finished. And it took like, this cannot be true, this number. It didn't take 1.5 hours. I will look at this. But anyway, we have a nice model. So we can again look for how well the cylinders fit by moving those sliders, making the points larger. We can also make the tree model transparent so it vanishes slowly, and we see that is already a pretty decent fit. And to check again, that have been our parameters, and now I can press this button to write some comma separated value files, and it's still not done. This button, oh, it takes long. Now it's done. This button to write ply models which you could import in Cloud Compare. Whenever this window gets gray, it means it's computing something. So it's done. We have saved our results. We have checked a little bit. It looks decent. I mean, I know this cloud very well. It could be better. So here are plotted the parameters which I put in, and a little bit down we have this parameter optimization. Here are the better parameter which my program did find. So we see here numbers which I never would put by try and error. And that's all. The parameter search did take quite a long time, but the real tree modeling was done in 5 seconds when I found the parameters. And that's all for now. I will explain in another tutorial how to how to work with the comma separated value files and the ply files. That is part 2, but I will and one more last thing here. If you see here a well-formed function like this, you also know you have a really good model. That is quite impressive, but we talk about this later. So goodbye.